there's one type of autonomous agent use case that has been trending really fast for the past few weeks. And we see multiple teams made huge progress towards this direction. From Hyperride teams publish a self-operating computer framework where they let GPT4V to have direct access and control of your whole computer. So you can open Spotlight to search for any apps like Google Chrome, conduct actions like search for a specific URL, go to Google Doc, write a whole blog with your Google account, as well as more advanced actions like browse internet, order pizza, book flight tickets. On the other hand, we also see team from Multi where they showcase a web AI agent that has direct access to the web browser, and it completes California online driving test successfully by itself. This is the first fully autonomous completion of real-world human knowledge task by AI. So this type of agent system where it gives super powerful multimodal model like GPT4V direct computer access to let it become a self-operating computer is such a fascinating idea, as it seems like unlocks so much potentials. So I did a bit of research and experimentation, and today I want to talk about what are the use cases and opportunities I see that those self-operating computer can enable. And in the end, I'm going to take you through an example walkthrough of how to build an AI that have direct control of your web browser and do sophisticated web research and tasks. So let's get it. Firstly, let's talk about what are the use cases and market opportunities this can potentially unlock. One way for me to look at this is what were the previous attempts when people tried to build such a similar system? What were the use case and limitations? And what are the new technology or changes now that can potentially change the dynamic? One very direct market category, in my opinion, is RPA, which represents for robotic process automation. It is basically a category of software that help enterprise to build automated robot that can handle repetitive and standardized tasks like handle invoice or data entry jobs. One of the most representative platform in this category is UiPath, where they build a platform that allow you to build Zapier type of automation to access and interact directly with your desktop apps. From calculators, browser interactions, as well as Excel or legacy system that has no API endpoint that can be used. And this provides huge amount of value to enterprise where they have a lot of admin tasks that is simply move data from one system to another. It is fast growing segment, where at 2022, enterprise already spend more than $3 billion every year on those process automation. But the limitation of those RPA solutions are also quite clear. Most of those systems can't really handle non-standardized or ever-changing process, not to mention process that involve more complex decision-making. For example, let's say I am shoe brand and I want the robot to do the data scraping of the pricing and product from Nike, Adidas, and Puma. I actually need to build a very specific process for every single website because each website structure is different. And if one of them update the website structure, the previous automation is going to break as well. So every single RPA process you build is very specific and can be fragile to any environment change. Thus, the setup cost is very high. That's why currently all those RPA are mainly used for enterprise where they have standardized and repetitive tasks that has huge volume to justify the cost. But that's also why those multimodal AI agents that can directly control the computer and browser is so exciting. Because theoretically, they can handle much more complex situations with much less setup cost. In the data scraping example, instead of me setting up very specific automation to tell robot that you need to look at this HTML tag to get this, I can simply give agent URL of different competitors and let it automatically navigate the website, take a screenshot, and extract data regardless of format change because agent will do the decision making itself. And on the other hand, those AI agents can go way beyond just automation. It can complete intelligent tasks, like for a customer support agent, you can look through the conversation history with the customer, summarize it, and automatically fill in the metadata and escalate to the right team. So if done well, I believe this web AI agent can potentially open up the market for consumer use case that has much less volume and also go beyond just normal automation, but complete the actual digital worker job like customer support, sales, and marketing. As agent has the ability to access more and more different systems, I feel we're definitely getting closer and closer to have those real AI workers to be deployed in the companies. However, I often found the big gap to deliver usable AI worker solution is not necessarily just the understanding of technology, also the understanding of the end-to-end workflow for specific job functions. That's why I want to introduce you to a research report that Hubspot just did, where they surveyed and interviewed more than 1,400 global sales leaders to really understand how does a modern sales rep team works. What does their whole end-to-end workflow look like? They cover a lot of insights from the key challenges and opportunities the sales team are facing in 2024. as well as how big amount of sales reps shift into relationship building, which involves a lot of tedious admin tasks. They also dive into the best practice as well as the top AI use case those sales leaders are adopting at the moment. So this gave me a super useful deep dive of how sales function works and what are the key opportunities there. I found it super useful. So if you're trying to build an AI agent for sales function, I definitely recommend you go have a look. You can click on the link in the description below to download this report for free. Now let's back to building an AI web agent. But how can we get the AI agent to actually control the browser or even the whole computer? There are two common implementations so far. One method is designed before multimodal model like GPT4V is available, where they basically get a whole HTML DOM, which represent the web page, simplify a little bit, and send as part of prompt to GPT 3.5 or GPT-4 to let it decide what's the next step. Should the agent interact with this specific DOM element, which could be a button or input box or a link to navigate to? And based on the output of GPT, it will do the actual interaction with the web browser through common library like Puppeteer, Selenium, or Playwright. Those are all frameworks that has been designed before for end-to-end testing for web applications, which means they have ability to interact with web apps. And one project that is quite representative is called Taxi AI, where they develop an open source Chrome plugin that people can give a specific task, like create a calendar event, where it will pass the whole DOM to GPT-4, let it decide what should be done next. It is already able to interact with a few popular websites, like searching and play specific movie on Netflix, create a calendar event on Google Calendar. The downside of this method is very clear because it is sending the DOM to large language model. So there's a huge amount of noise that has been censored. So it is very slow, costs a lot of money because we are sending a lot of information, and often large language model is not able to do accurate interaction as the information is not clean. But with multimodal like GPT-4V, the solution seems a lot more viable. The solution is often take a screenshot of the web page of desktop computer, draw different bounding box on the web page to annotate parts that can be interactive. So GPT-4V can give better instruction about which element to interact with. And from research, by giving proper annotation, GPT-4V can complete tasks much better. So you basically take screenshot, generate annotation, send the screenshot with annotation to multimodal model like GPT-4V so that it can give instruction about what's the next step. Then again, use those common libraries to control the computer or browser. And this is exactly how the self-operating computer framework works. If you try out the self-operating computer GitHub link, you will see the way it works. It will take a screenshot of your current desktop computer, add a simple annotation by dividing the screen into different grades. So GPT-4V can use this to communicate where to click, and they give a prompt to GPT-4V that giving the screenshot and a go, it should output 4 different outcomes. It can be either simulate a mouse click interaction, type on a keyboard, or search, which is a spotlight search function on MacBook that can be used for quickly access the application. And depends on the types of output, GPT-4V can call different functions. If it is mouse click, it will output a JSON format about the position it should click, including the X and Y, based on the percentage information on the grade, and then call different actions from mouse click to keyboard type to search. And the actual interaction is done by a package called autogpt, which is a Python package that can simulate those computer interactions like a mouse click and the keyboard interaction. For example, I can try to run this self-operating computer by open terminal and try operate. It will open this, and I can click OK to start and give instruction what is the latest weather in Sydney, Australia, and click enter. It will first take a screenshot, as you can see on the top, and then feed the screenshot to GPT-4V, which open the Chrome. And then it will focus on the URL input bar, typing the information Sydney, Australia weather, and take a screenshot again to feed this information back to GPT-4V. And once it's finished, it will output the information here that the latest weather information in Sydney is this one. However, the main challenge at the moment is I don't think this percentage grade annotation is working really well. I can often see the mouse interaction stuck at some weird position. That's probably because GPT-4V failed to give very accurate estimation about the percentage. But on the other hand, I'm also not too sure what's better solution would be because it is desktop computer. There's no easy way to manipulate and create bounding box. However, if we change the scope of AI agent to just web browser, then the accuracy should be much higher because we can easily use CSS to create those bounding box for web pages and give much more accurate annotation for GPT-4V. And this is the example I want to take you through today. I'm going to show you a step-by-step example of how can you build a web AI agent that can automatically navigate through the website to do research and web tasks. Based on an example provided by Unconventional Coding, where he built a GPT-4V powered web scraper. This really made the whole project a lot easier, so big thanks. So let's try to build an AI agent that can view and interact with your web browser. And I will take you through 2 examples. First, let's try to build a simple GPT4V powered web scraper, which can take a screenshot of a web page and then use GPT4V to scrape the data. And this will be extremely useful because it will be using your own web browser, so it can access websites that is commonly hard to access, like LinkedIn, Instagram, or other websites that normally block the scraping service. And after that, I will also show you a more advanced version. We will create a web AI agent who can browse internet like human does by looking at the web page, find a link that is interactable, and click on this link to find information further so that it can do quite sophisticated research. After this, you should have a good idea about how can you build an AI agent that can control your web browser or your computer. So let's get it. For the first one, GPT4V powered web scraper, we will use a Node.js library called Puppeteer to actually take screenshots and control the web browser. To do that, let's first open Visual Studio Code, create a file called screenshot.js. We will first import the library Puppeteer, and then we'll also use a plugin called Puppeteer Extra Plugin Stills. So this is one plugin that will make this auto web browser less detectable for website. And then I will define URL that we want to script. And in here, I just use a normal Wikipedia page to test. I will also define timeout, as some web page can be quite long to browse. And then I'll create an async function. So inside our firstly use browser equal to await puppeteer.launch to create a new browser and open a new page, set the viewpoint, which is how big a screen should be, and then do page.goto, which will open the specific URL that we defined above. And I do wait until document loaded. So this means this function will only be considered as finished after the whole DOM HTML content is loaded. And then I will do page.screenshot to actually take a screenshot of the page, save it as screenshot.jpg, and full page equal to full. And in the end, I'll close this browser to finish the session. So this simple function should actually open this page and take a screenshot. And before we run this function, we will need to set up this Node.js project. I will do npm initiate, and I can just leave everything to be empty, and you will see package.json be created already. And next thing is I will need to install Puppeteer. So I will do npm install Puppeteer. And once it's finished, you will see package log.json. That will automatically log all the packages that has been used for this project. And on the other hand, also need to do npm install Puppeteer extra. And now we can try to run this by doing node screenshot.js. Okay, so on the left side, you can see a new file called screenshot.jpg has been generated. If you open inside, it is a screenshot of this Wikipedia page. So that means this screenshot is actually working. But the problem is with what we have here now, it will not use my existing Chrome profile, which means it won't be able to access websites like LinkedIn, Instagram, or any other website that I have paid a subscription on. So you will need to download a special Chrome version called Chrome Canary. And then I will go to a special folder from users, your username, library, application support, Google. And inside Chrome, you will have default folder. I will copy this folder and go back to the Chrome and open Chrome Canary folder. Then paste in this default folder and replace existing one. So this will copy all my old cookie and profile from the other account to this one. And after that, I will open Google Chrome Canary and try to log in with all the accounts I need, like LinkedIn, Instagram. And then I will come back to screenshot.js. First, they add a executable path. This basically means which Google Chrome version Puppeteer should open. And in my case, it will be the Google Canary version. And also the user data directory. I will point to Google Chrome Canary /default, which is default profile. But if you want to change this to be other profile, you can change it to like profile 1 or profile 2. And I will also add a wait for timeout function here as well, because sometimes the web page can take a while to load. So with this, Puppeteer should be able to access any website possible with my own Chrome profile. Let's try this. I can try again by doing node screenshot.js. And once finished, I should take a screenshot of a LinkedIn web page with the full page length. And you can play with the timeout value a bit more, depends on your internet speed. So this JS file will be able to take a screenshot of any website. Next step is we want to create a Python file that can call this JavaScript file to take a screenshot and then let GPT4V to extract data from this screenshot. So I will create a visionscraper.py file and also a .env file to store the OpenAI API key. And inside Vision Scraper, we will import a few different libraries, load the env file, and also create a model with OpenAI. So I will firstly create a function called image_bef64. This will basically read the image file into a format that can be passed on to GPT4V. And second function called URL to screenshot, which will take a URL of the website, remove the old screenshot file if it exists, and then try to run the screenshot.js file by using subprocess. After running this, if there's no screenshot taken, it will show error. But if there are screenshots taken, it will return the screenshot file. And then we'll pass on this screenshot file to GPT4V by calling this function called vision extract. Inside, I will create a chat completion with GPT4V. I'll give a system prompt that you are a web scraper. Your job is to extract information based on screenshot of website and user instruction. And then send a second message with image file as well as a user prompt. In the end, it will display the result returned from GPT4V. And last but not least, we will connect everything together with a function called vision crow. It will generate image first and then return the extracted information. So that's pretty much it. We can try it out by call vision crow. I will pass on a LinkedIn profile and then say extract Jason's working experience profile based on the screenshot. So I'll do Python vision scraper.py. Oh, sorry, there's typo for this JS file. On the line 23, I will need to change it to screenshot. And one thing I forgot to do is for screenshot.js, I will need to replace the URL to be process argument value 2. So this is basically referring to a third argument passed from the Python file, which is the URL. And let's try this again by doing Python vision scraper. So image has been captured and passed on to GPT4V. So it actually look at the screenshot and return my working experience. And this result is a lot better and cleaner than the normal scraping service, especially if you try out some more complex website like pricing page. So I can try this pricing page of Relevance AI, the URL, and then say extract the pricing info and do it again. It successfully get the whole page of the pricing. And then it returns the full details of this pricing page. And for this type of task, if you do it through normal browser-less scraping, the result is a lot more messy. But with this one, it will be able to capture all the details by GPT4V. So now you just create a simple but super powerful web scraper that is probably better than any other scraper you will get. But next is we want to do something more advanced. Build an AI web agent that can actually interact with different websites. Click on the links to navigate around to do research. And if needed, it can even fill in the text input and forms. I'll create a new JS file called webagent.js. We'll import a list of different libraries. And if you haven't, you will need to install a new package for OpenAI as well by doing npm install OpenAI. And then we'll try to create an OpenAI instance as well as timeout as we did before. And after that, again, we'll need to create this image to base 64, which will convert the local image into something that can be passed on to GPT4V. And then we'll create a simple command line interface that allows users to type in the prompt as well as sleep function to set a timer so that it can wait for the page to be fully loaded when it is browsing the website. And after that, we will create a very important function called highlight links. So the purpose of that is, if you remember, we want to create some bounding box to highlight the elements that can be interacted. So the way it works is that it will firstly try to remove all the previous highlighted bounding box, and then return all the button, input, text area, as well as the links available on the web page. And for each button or links, we will create a function inside called isElementVisible, which it will go through a few criteria to making sure the width, height, opacity, display visibility is not hidden, and also the element is within the viewpoint. And in the end, it will return a true or false value about whether this element is visible. And it will first create a border for all the interactive elements. And if the element is visible on the page, it will clean up the link text and also set a special attribute for that specific DOM element called GPT link text, so that later we can use this as an identifier of what elements Puppeteer should interact with, as well as a wait for event feature. So this will be used when we want the AI agent to be only executed after a certain event is happening, like page load. And that's pretty much all the function we need. In the end, we just stitch them together. So we'll define the Puppeteer browser, create a new page, set a viewpoint, and we'll define a system message. You are a website crawler. You'll be given instruction about what to do by browsing. You are connected to web browser and you will be able to given a screenshot of website you're on. The links on the website will be highlighted in red in the screenshot, and always read what is in the screenshot. Don't make up link names. And you can go to specific URL by answering the follow JSON format URL, or you can click on the links on the website by referencing the text inside the link button. By answering specific format, click. And once you find the answer, you can try to answer with regular message. And in the beginning, go to the direct URL that you think might contain the answer to the user question. If possible, use Google search. And then we'll do a console log, GPT, how can I access you today? Let the user to input the prompt, push the user prompt as part of the message, then generate variable URL and screenshot taken. Then we'll create a loop so the agent can continue to navigate between different pages until it thinks the task has been completed. Where we will define some special behavior for situation when the screenshot is already taken, as well as a URL has been defined, but we'll come back to this later. And at top, we'll have some special code to handle situation after a screenshot is taken, or GPT4V generate a link that it should be scripted. But I will come back to this later. So firstly, we will call the GPT4V and get a response back with the system message as well as a user prompt. And after that, we'll try to get and display the message to the user in the terminal. And then if the message that GPT returned is in the format like click, which means the agent will want to click on a specific UI element on the website, and then it will try to get text of the links that the agent will want to interact with. Display a message to the user that the agent is trying to clicking on a specific button. And then we'll try to fetch all the elements that has that special attribute, GPT link text. And we'll try to do a match. So for each interactive element, we will try to match whether the link text that agent want to interact with is either partial or exact same as the link text on the HTML. And then it will try to interact with that web element by doing .click. And after that clicking interaction happen, which could either take the user to a different page or open a specific menu, it will try to take a screenshot and also set the screenshot taken to be true. But if the agent message is not click something, but it return a URL that it want to fetch, then we will try to get the URL that the agent want to return and then continue the loop. And now let's try to get back to the top. So this is where these two conditions will be used. So if a URL exists, which means the agent return message that it want to script a certain website, then we'll display message that the agent is crawling certain page, go to that specific URL, and after that page is loaded, we will highlight all the links, wait till the page to be fully loaded, and highlight all the links on the page and take a screenshot. Then set a screenshot taken to be true. And the other condition, if screenshot is taken equal to true, which means either the web browser has jumped to the new URL that the agent wants to script, or the agent has clicked on a specific button and take a screenshot of the interacted state already. Then we will load the image and pass on the image to the GPT4V and tell it, here's a screenshot of website you are on right now. You can click on the links or you can crawl to another URL if needed. If you find the answer to the user question already, you can respond normally. Then set screenshot taken to be false. And after that, we'll trigger the message to GPT4V and get a response back. So this is how the while loop here works. The agent will basically continuously click on different links to navigate further to find information needed or scraping new website links. After the agent finish everything, then we'll display the result to the user and let user to give further instructions. So this is basically a web agent that we just created. Now let's try to run this. I will open terminal to node webagent.js. I can give an instruction. What's the weather like in Sydney? So it will firstly try to script the website and then return answer that in Sydney currently is around 20 degrees. And if you click on the screenshot.jpg, it actually go to Google, highlight all the interactive links or input box, which means it will be able to script further if it needs, and also read the information on the page. And to test its ability to interact with the website, I can ask a follow-up question. Give me 10 days weather forecast for North Sydney. And if the agent is smart, it should be able to click on that specific link to get more information. So I click enter. It return message, click on 10 days weather North Sydney, which is that specific link. As you can see, it successfully navigated to the next page, and which has 10 days forecast information. And then GPT4V read and return the list of answer to me. On the other side, I can also ask this AI agent to complete some sophisticated tasks. For example, I quite like the Instagram account Epic Travels, and I want GPT4V to figure out how can a company or business to be featured on Epic Travels. So I'll give task, figure out how to be featured on Instagram account Epic Travel. So it will do a Google search first, and then click on Epic Travel's Instagram account and load the whole Instagram information. And it finds its own official website, get information, and then return me the proper answer. So this is a perfect example of how this web AI agent is able to navigate through multiple different websites to find the information you want. And at the moment, this functionality is still quite limited as it didn't really implement the functionality of interact with form elements, and clicking link can often go wrong as well. So there's lots of area to improve. But already it shows huge potential to complete complex tasks. That's it for today. I really look forward to different type of AI agents that you're going to create that can have innovative interaction with web browser or computer. I will continue posting interesting projects that I'm doing, so please consider giving me a subscribe if you like this. Thank you, and I see you next time.